Question 2.1. Complete the diagram of the apparatus used to distill the cyclohexene from the reaction mixture at 83 degrees C. So I've got a reaction mixture. It contains a mixture of cyclohexene, presumed with some water or something like that. I've got some anti-bump granules to stop big bubbles forming, and I'm heating it up. I'm expecting the two different the cyclohexene and the water will boil at different temperatures, and as they boil they'll come down this tube here. I want to measure the temperature as they come down this tube here. I'll need a condenser with some water in and water out to cool the gases back down into a liquid, and I'll want a thermometer here with its bulb level with the outlet tube, and I'll need a bung to stop the gases escaping. So I'm going to need a thermometer with a bung, bulb level with the side arm, condenser jacket, a sort of condenser with water going through it. Water goes in the bottom and out of the top. So it's going to look like that. Make sure your bung touches the side so that there's a neat fit. Make sure the bulb of the thermometer is at the bottom, and then make sure you've got a condenser that looks like this with an open tube going right down the middle, and then another tube going around the outside which is going to have water in and water out. So it looks like that for all of the marks, all of the 2 marks. The distillate was shaken with saturated sodium chloride solution. The cyclohexene was separated from the aqueous solution using a separating funnel. Explain how a separating funnel works. Well, a separating funnel looks like this. You have 2 different layers that don't mix, maybe like oil and water or something like that. Those 2 layers that don't mix are called immiscible, and what you do is you turn the tap and you run the bottom layer off, and when the top layer gets down to the bottom, then you close the tap. So it's just a physical process where 2 liquids are immiscible, don't mix, and you run the bottom layer off by opening the tap, and you close the tap before the top layer runs through, and you can collect the lower layer then in a beaker or something like that in a container. The cyclohexane separated was obtained as a cloudy liquid. The student dried this cyclohexane by adding a few lumps of anhydrous calcium chloride. That's good compound calcium chloride to remove water. It's cloudy presumably because it's got the cyclohexene has still got a little bit of water in there, little water droplets in there that will make it cloudy. Give one observation the student made to confirm the cyclohexane was dry, in other words the water had removed. Presumably it's going to lose its cloudy water droplets. It's going to go clear or no longer cloudy. In this preparation, the student added an excess of concentrated phosphoric acid to the cyclohexanol, and it made cyclohexene. Concentrated phosphoric acid is very similar to concentrated sulfuric acid. It will remove water and remove an OH and an H on an adjacent carbon to remove water, leave a double bond, hence the cyclohexene. Calculate the percentage yield of cyclohexene obtained, give your answer to the appropriate number of significant figures. So let's have a look here. So cyclohexanol, I've been given a mass and an MR. The only reason I've been given a mass and an MR is to work out number of moles. So moles is mass divided by MR, 14.4 divided by 100, 0.144 moles of cyclohexanol. Now the cyclohexanol makes cyclohexene. You can see from cyclo, it's going to be 6 carbons in cyclohexanol and 6 carbons in cyclohexene. So 1 mole of cyclohexanol is going to make 1 mole of cyclohexene. So it should make the same number of moles of cyclohexene from the cyclohexanol, 0.114. What else do I know then? I know the MR of cyclohexene. It's been given me that as 82. I know the number of moles of cyclohexene. So moles is mass divided by MR. So mass is moles multiplied by MR. And I multiply the number of moles of cyclohexene, 0.144 by 82, which is the MR. I should make 11.81 grams of cyclohexene. The mass of cyclohexene actually formed then, how can I work that out? Well, I've got a density. Why would I be given density? Density is mass over volume. So maybe I can work out if I've got the volume. I've got the volume 4.15 centimetre cubed. Look at density, it's in grams per centimetre cubed. So it'll give you density is mass divided by volume. The volume needs to be in centimetre cubed, and it already is. So density 0.180 equals the mass divided by the volume 4.15. So the mass is 0.810 multiplied by 4.15. I should make, so I actually did make 3.36 grams, and I should have made 11.81 grams. So percentage yield is smaller divided by larger. 3.36 divided by 11.81 multiplied by 100%, 28.45. Now it says the correct number of significant figures. I've got 3 significant figures, 3 significant figures, 3 significant figures. It needs to be 3 significant figures. So I'm going to round it up to 28.5% is to 3 significant figures. Cyclohexene reacts with bromine. Complete the mechanism for this reaction. Well, electrons will come from a double bond, just like when you get electrophilic addition with HBr. Then the electrons go from the double bond towards the Br, and then the Br is going to join onto one of the 2 carbons. So double bond goes onto here, and the Br joins onto one of the 2 carbons. It doesn't really matter which one, but it'll join onto one, and the other one hasn't got enough bonds, hasn't got enough electrons, is plus charged. And then the Br minus, which has come here, look, the Br minus, the bond has broken, the electrons have gone onto the Br, so there's the pair of electrons from the bond gone onto the Br. It's had electrons moved onto it, so it's got a minus charge, and those electrons, remember, an arrow can come from a double bond, a single bond, a pair of electrons, or a ring, and it will attack then that plus charge there and join on, and that's your mechanism, electrophilic addition of BrBr, similar to HBr or sulfuric acid.